Graph y equals negative 1/2 x squared plus 3. Compare the graph with the graph of y equals x squared. So y equals x squared is my parent function. I'm going to start out with making its table. I'm going to use -2, -1, 0, 1, and 2. And that gives me 4, 1, 0, 1, and 4. I'm going to go ahead and graph that equation. Y equals x squared, 0, 0, 1, 1, -1, -1, and 2, 4, and -2, 4. So here's our parent function. This side's not as good. There we go. And so we want to graph y equals negative 1/2 x squared plus 3. So one thing is we need to know how do these numbers transform the parent function y equals x squared? Well, the negative we know reflects the graph across the x-axis, so it makes it open down. The 1/2 is going to shrink the graph or compress it. And then we know that the plus 3 will shift the graph up 3. So if we want to just show how these transformations take place, we start with our stretching. And I'm going to take all these y values and multiply them by negative 1/2. So 4 times negative half gives me -2. 1 times negative half gives me negative 1/2. 0 times negative 1/2 gives me 0. 1 times negative 1/2 gives me negative 1/2. And then 4 times negative 1/2 gives me -2 also. All right, so this x values with these y2 just gives us this part of our equation. So that is our stretching part. And then we're going to add 3 to all these y values. So -2 plus 3 gives me 1. And I can go down here, -2 plus 3 gives me 1 also. I know that 0 plus 3 gives me 3. And then we just need to do negative 1/2. So let's say we're at negative 1/2 and we add 3. So that means we're going to move it up 3 units. That's 1, 2, 3. That puts me at 2.5, but because we're at 2.5. And then it's going to be the same here. All right. So all we have to do is we're going to plot these x values with these y values, and we'll have the equation y equals negative 1/2 x plus 3. So let me go back to the pen. I'll change colors. We'll go with black. I have -2, which is right here, and I'm at 1. At -1, I'm at 2.5. 1, 2.5. At 0, I'm at 3. 1, 2, 3. At 1, I'm at 2.5. And then at 2, I'm at 1. So here's our new graph. So you can tell that it's been reflected across the x where it opens down. It's wider, it's been compressed because we multiply by a number that's smaller than 1, that 1/2. And then it's also shifted the graph up 3 units because we added 3 to it. And also notice that your axis of symmetry goes through your vertex. It divides it in half. These points on the left are exact same units or distance from this axis of symmetry as the points on the right. So for example, this point is 1, 2 to the left of the axis of symmetry. And this point right here is 1, 2 to the right. This point right here is 1 unit to the left of the axis of symmetry. This point is 1 unit to the right. So if you ever graph and you get one side of the parabola, all you really have to do is reflect those points across and you can get your right side. So keep that in mind. If you don't want to go through all the shifting, you can make a table and directly substitute and then plot those points. So let me just show you a few of those. So if I have y equals negative 1/2, in place of x I'm going to put in a -2, that's squared plus 3. use your order of operations. Negative 2 squared is 4. 4 times negative half is negative 2, and then negative 2 plus 3 gives you 1, which is the exact same point we have here, negative 2, 1. And I can go y equals negative 1 half. I can plug in a negative 1. So negative 1 squared is 1 times negative half is negative a half. And if you take negative 1 half and you add 3 to it, you will get 2.5 or 2.5, however you want to write that. Then I can plug in 0. 0 squared is 0 times negative 1 half is 0 plus 3 gives me 3. Again, these are the same points you see right here. And I know that this will be at 1 is 2.5, at 2 is going to be 1. If I plot those points, I get these same exact points right here. And I can connect my dots and I have my graph. So you can either directly substitute it or use the transformations from the equation to get your new graph.